Hi, welcome back to LeetCode. In this video, I'm going to discuss LeetCode problem 3335, total characters in string after transformations 1. So you are given a string s and an integer t. So t represents the number of transformation to perform. So in one transformation, every character in s is replaced according to the following rules. So if the character is z, replaced it with the string ab, and otherwise like a to y, if the character is from a to y, any one of this, so they are replaced with the next character. So L will be replaced with B, B will be replaced with C, C will be replaced with D. In this way, Y will be replaced with Z, but Z will be replaced with AB. Okay. Now, what we have to do? We have to return the length of the resulting string after exactly T transformation. So the answer may be very large. Return the modulo of 10 to the power 9 plus 7. So let's go to the example 1. What they're trying to do: A, B, C, Y, Y. Y, Y. Now they mention that two transformations actually we can do. So after first transformation, what will be the string? A will be replaced with B, B will be replaced with C, C will be replaced with D, Y will be replaced with Z, Y will be replaced with Z. So this will be the string after transformation 1, correct? Now again we can do another transformation, because maximum maximum means exactly two times actually we have to call the transformation. So now B will be replaced with C, C will be replaced with D, D will be replaced with E, Z will be replaced with AB. Again another Z is still present, that's why it will be again AB. Now this is the final string. Now what is the length of this? 3, 5, 7. So 7. So now we have to return 7 here. Clear? Example 1 is clear. Now go to the example 2. String S is A, Z, B, K. T is equal to 1. Okay. So after transformation 1, what will the string look like? A will be replaced with B, Z will be replaced with AB, B will be replaced with C, K will be replaced with L. So this will be the final string. Now what is the length of this? 5, correct? So you have to return actually here 5. Now it is clear. Now they mention that the string length can be 10 to the 5, string length, and T can be 10 to the 5 maximum. Now what is the brute force approach we can think about this? Now we will have any string A, B, C, D, E. This will be a string, and suppose we have actually any T. So after transformation 1, actually we can actually think about what? We can actually generate the new string. What will be the string after transformation 1? Then actually we can go to the next transformation and we can generate new string. Suppose after transformation 1, what will be the new string? It will be A will be replaced with B, B will be replaced with C, C will be replaced with D, D will be replaced with E, E will be replaced with F. So this will be the string after transformation 1. Then after transformation 2, what is the string of this new string? String 2, B will be replaced with C, C will be replaced with D, D will be replaced with E, E will be replaced with F, F will be replaced with G. Okay. So suppose we actually mentioned that maximum exact 2 transformation we actually call. So now we have to return the length of the string. So this is the ultimate final string. So what is the length of this? 5. So we have to return 5 here. Okay. Now we have got another string. Suppose A, B, C, Z. Now after transformation 1, what will be the string? A will be replaced with B, B will be replaced with C, C will be replaced with D, Z will be replaced with AB. Correct? Now again we got another transformation. T transformation 2. What will the string look like? B will be replaced with C, D, D will be replaced with E, A will be replaced with B, B will be replaced with C. Correct? So now again the transformation number is 2. So what will be the length of this? Length of this is 5. So you have to return 5 here. Input length was 4, string length 4, but here actually 5. We have to return 5 here. Okay. So what actually we are doing? We are actually generating the new string after each transformation, and then actually we actually try at the end ultimately whatever the final string actually we have, and we are checking that what is the length of that. So that will return. Correct. So what will the time sort of this? Say suppose there are 3 transformation are there. So 3 transformation we call. So after each transformation, what are we doing? We are iterating the inputs, the string, input string. Then we are creating the new character or the new string. So we have to traverse the input string character by character. So if the length of the string is suppose n, so it will take actually n times big of n, and t times t transformation we call. So the time should be t into n. It is clear. So t range is 10 to the power 5 and n length can be, string length can go up to 10 to the power 5. So what are the times root of this? 10 to the power 10. So this will give us a TLE. It is clear why it will give us TLE, and the approach also is a brute force approach. Now we are trying to optimize this. How? What actually we have actually? Ultimately they want to know the length of the string, not the final string ultimately, right? They do not know about the what string will look like. They want to know the length of the final string. Now suppose this is a string A, B, C, D. So after transformation 1, what will the string look like? B, C, D, E. So what is the frequency of A here? 1. B is frequency 1 here. C frequency is 1. D frequency is 1. Now for this new string after transformation 1, what is the frequency of B? 1. C is 1. D is 1. And E is 1. Now you can check in the new string here frequency of A is 0. So ultimately what you are doing, whatever the number of A is present in the old string, that is converted into the B character B. So you can check what is the frequency of in the A in the old string, A 1, and similarly now frequency of B will be 1. This will be actually interrelated, correct? Because we are converting A will be replaced with B. Now whatever the number of B present in the old string, how many times, how many numbers of frequency is 1. So that will be exactly equal to the C in the new string, correct? Ultimately B will be replaced with C. Similarly for how many times C is present in the old string, 1. So this will be actually converted to D, correct? Similarly for D in the old string, that will be converted to E. So the frequency of E in the new string will be same as the D present in the old string, correct? Now suppose there are actually any, this is correct. Ultimately we will check what this is actually transformation 1. Now we will check what is the frequency of the each character now. So what is the frequency of character? B is present 1, 1 plus 1 plus 1. So this is ultimately 4. So we return 4 after transformation 1. Now we have another string. Suppose A, B, C, Z. Okay. So what is the initial frequency? A is present 1, B is present 1, C is present 1, Z is present 1. Okay. So if we do it manually, like brute force approach, we are actually trying to convert this string to trying to generate the new string. So A will be converted to B, C, D, A, B. Okay. So ultimately what is the frequency of A here? 1. What is the frequency of B here? 2. C is 1. D is 1. Correct? Now we have to relate this. How? Like how many times A is present here actually? This will actually convert to B in the new string. So you can check. Okay. But still actually we have only 1. We got a 1 from this A to B. From B, this will convert to C. The frequency is equal. Correct? Now for C, it will convert to D. So the frequency is equal to, both are equal. Now for Z, what actually it will contribute in the new string? It will contribute A and B. So you can check A frequency is increased by 1 and B will be again increased by 1. That's why frequency of B is 2. 1 for A coming from A, and because A will be replaced with B in the new string, and 1 coming from Z for the frequency of B. Correct? Got it? So what will do? And ultimately what is the, now this is the new frequency of each character. So what is the ultimate frequency? 1 plus 2 plus 1 plus 1. So this is check 5. So this is after transformation the length of the new string 5. Got it? What are you trying to do? Like we will have the initial frequency of each character. Now for after each transformation, I will create a new frequency of each character. Like frequency of B will be like new frequency of B. It will be the old frequency of A. Correct? Then new frequency of C. It will be actually the old frequency of B in the new string, in the old string. Correct? Now what will do? The new frequency of A will be what? Old frequency of Z. Correct? And new frequency of B will be what? Addition to new B, whatever the new B coming from this old A, that will be always there, plus coming from Z. It will contribute from old Z also. Correct? For whatever the frequency of B will be in the new string, one coming from A, this is coming from ultimately A, and this is coming from ultimately Z. Got it? and for what are the frequency of A in the new string will be the what are the frequency present in the Z. It is clear what are doing. Ultimately, what are the frequency we have in the frequency vector, that will actually sum of that frequency will give us the total length of the ultimate string, final string, correct. Now go to the actually code. So the frequency we have actually maximum 26 character. So initially frequency will be 0, and what I'll do, we'll first count the frequency of each character, and I am iterating the input string and I am increasing the frequency of each character. So suppose A will be frequency of 1, B will be 1, C will be 1, Z will be 1. Okay, this is the frequency. This frequency vector will contain this, and else any other index value will be 0. Now what we'll do, we'll call this transformation function t times, and after each transformation what we'll do, we'll create a new like our frequency will be A will be shifted to B, frequency of B will be shifted that. So what I'll do, I'm storing the first of all what is the frequency of Z, okay, in temporary vector. So I have stored that one Z is still present in the old string. Okay, now what I'll do, I will shifted A to B, B to C, C to D in this way. So what I'll do, I'm traversing backward from Z is equal to from 4 means Y to A. So now what I'll do, I will I will assign the frequency of A to the frequency of B. You can check frequency of J plus 1 assigning the frequency of J, just shifting this. You can use another new vector of frequency, another frequency 1, 26 size, you can do that, but I am actually using the only one vector. Okay, so I am just shifting this. Suppose this is actually the A, B, C, D, E. So this is suppose 1, 1, 1, 0. So after one transformation, what will happen? After one transformation, D frequency will be 1, C frequency will be 1, and this will be 1, and this will be 0. Correct. Correct. Now you can check we are doing this for this index we are shifting this J plus 1. This is J, so J plus 1 I am assigning 1. Now for this J, this is J, so J plus 1 it will be shifting 1. Okay, we are writing 1 here. Similarly for this number of this is currently J, this is currently J, J is equal to 0. In J plus 1 what I am writing? I am writing 1 here. Okay, and in the here actually I have written 0. Okay, now what I'll do, I have actually shifted from A to Y. Whatever the actually A to Y actually present, that will be I have actually shifted this into the next character, correct. Now for Z actually we have to handle this. For Z actually we have to handle this in different way. How? Like frequency of B will be increased by what? Whatever the frequency Z actually present that times, and whatever the number of A present in the old string, that will coming from frequency of 0. I have already modified this frequency 0. Correct. Frequency 0 means how many actually A actually present, and that will be add like A, whatever the A coming to B and Z coming to B, this will be actually add, this will be add, and I have to take the modulo of 10 to the power 9 plus 7 because I mentioned that, and frequency of A will, this is for B and this is for A, will be whatever the number of Z actually present in the old string, that will be assigned to the number of A. Frequency of A will be that time. Okay, so for this string, for this frequency, whatever the new frequency of this, like B will be again 1, C will be 1, D will be 1, and Z will be 0, and A will be what? 1 from Z, and this is for 1, or this is for Z. Got it? This is a new frequency map. A will be present 1 times, B will have twice, C will have 1, D will be have 1, Z will be now 0. Got it? It is clear. Now after transformation 1, I suppose this is T is equal to 1. So ultimately whatever the frequency present in the frequency vector, that actually total, if we sum that, if we take the sum of that total frequency, that will give the total length of the string, ultimate string. So if we take the total sum of this, so what is actually written? 1 plus 2 plus 1 plus 1. You can check what is the 5. So this is the ultimate string length. So that's why I am just iterating the frequency map and storing adding the value of this current frequency and taking the modulo of 10 to the power 9 plus 7 and return the answer. Got it? How actually optimize this? Like we are actually not creating the new string every time. We are just taking the frequency, whatever the frequency I have. So here actually we are not iterating the string input string length n. we are just returning 26 character only. Like frequency will be the same. Like frequency will be same means what? If we know the frequency, that will actually create the new length, right? So what is the time state of this? Like here actually we are iterating the input string, suppose n. Okay, so here actually we are actually, there is a for loop t times we are running this for loop, and we are actually 26 times roughly we are calling this for loop, nested for loop. So this will be 26 into t, and similarly for this will be actually 26, frequency map size is 26. So ultimately what will be time state of big of n plus t into 26 plus 26. It is clear? N for the input string and t into 26 for transformation number of times, and in every transformation we are calling this for loop 26 times. So and plus 26 is for this for loop, we are actually taking the sum of the frequency. Got it? And what is the space complexity? We have to take in a frequency map, that's actually 26 size, so this will be actually constant roughly, correct? Any other things we are taking any space? No. So it is clear. I have shared the my submission code link into the description. If you have any doubt, any suggestion, you can comment on that. Thank you. If you not yet subscribed, please subscribe the channel.